Okay, I see 2 nods. That's all that cares. Okay, so what is today's lesson? Today's lessons is sequences, right? Which is 9-1. We're going to do 9-1 and 9-2, okay? But I'm going to skip around. So I les aviso. I les digo, all right, this is 9-2 now, right? So what is sequences? Well, first of all, let me give you some notations. This is how you say this. You say A sub 1. This means the first term. A sub n is the nth term. So then what is a sequence? A sequence is this. A sequence is the domain, is a function, guys, a function. ¿Se acuerdan a function? Okay, it's a function whose domain is the positive integers. That means that this is going to be A0, even A0. A0 is okay. A0, A1, A2, A3, A4, but not A1.1, A1.2. ¿Me están entendiendo? So this right here is only positive integers. This domain, the n, in other words, this right here, the n will be only positive integers. So A sub n is the nth term. What do I mean? Well, give me a number, 25. So then this is the 25th term. So then what does this thing look like? Well, we can start out by doing this. Say that I gave you a function, A sub n equals 7n minus 1. This 7n minus 1 is called the rule, right? Now, when you have the rule, then I can start by saying, well, suppose that n starts at 1. Sometimes n starts at 0, sometimes it starts at 1. Let's just start at 1, okay, for the first term. A sub 1 is 7 times 1. So where did I get this 1 from? Well, that's n, see? This n and this n are the same. Have you seen that before? Well, do you remember this notation? F of x equals? This is now like f of x, but it's a of n. It's like a function of n. Are you with me? All right. So then again, plug in n is 1, n is 2, n is 3 for a1, a2, a3, and you get 6, 13, and 20. And now, what do you do with that? You develop a list, 6, 13, 20. This list is called a sequence. Okay? Now, let's say that I have this sequence. Are you with me or not? Suppose that I only gave you a sequence. I didn't start you out with the rule, 7n minus 1. I started you out with 6, 13, and 20. Let's come up with that rule over there. Okay, let's come up with that rule. Well, suppose that I have 6, 13, and 20. You're going to need 2 things. You're going to need A1, and you're going to need the D. Well, let's talk about this. What is A1? A1 you already have. A1 is your what? First term. You're welcome to turn on the volume if you want to answer, okay? I know some of you like to answer. I do. And then D is called the common difference. Well, how do you find the common difference? Well, I know that I'm going up by what here? To go from 6 to 13, I go up 7. 13 to 20, I go up 7. So then I know D is 7. But how can I find D? Well, this common difference D, I can find by taking a term, whatever that term is, say, and then subtracting the previous term. So then this is the term. For example, let's say K is 10. Well, 10 minus 1 is 9, no? So then A sub 10 minus A sub 9. Think about that. It's like taking 13 minus 6 or 20 minus 13. So then I can figure out D right away by saying, let's say D is 13 minus 6. I have 13 minus 6, okay? Now the rest of this is a formula, which is right here. Well, let's talk about this formula. A sub n equals A sub 1 plus D times n minus 1. What is this formula? This is the formula to find the nth term. But let's talk about how I came up with this. So I'm going to write it right here where you're doing your problem. A sub n equals A sub 1 plus D times n minus 1. I switched the D to the front. Usually the D goes at the end in most formulas in most books, okay? So what happens here? Well, think about this right here. How do I go from 6 to 13? I add what? 7. And then from 13 to 20, I add 7 plus 7 plus 7 plus 7 plus 7 plus 7 plus 7. If you can turn on your audio, can somebody tell me what that is a concept of? Plus 7, plus 7, plus 7, plus 7, plus 7, plus 7, plus 7. What is 7 plus 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 7? 49. How do I get there faster?
Multiply.
That's right.
7 squared.
That's right. No, not 7 squared. It's 7 times however many 7s I added, didn't I? If I go 7 plus 7 plus 7, what is that? 21. How do I get there faster?
Multiply.
Right. So then this is what that is. You're going to take the first term and add so many 7s. This D is 7, remember. How many? Not n 7s, but n minus 1 7s. ¿Sí? Porque para llegar, por ejemplo, de aquí a aquí, how many 7s do I add? To go from 6 to 20, how many 7s do I add?
2.
2, but yet this is a what?
3.
This is a 3. Are you with me or not? This is a 3. So then I found what? I found this n minus 1 formula here, okay? So first thing I did was find D, which is a number minus a previous number to get the common difference of 7. So then let's find this formula. AN equals, what is A1? Well, A1 is over here, 6. A1 is 6 plus, what is your common difference? 7 times n minus 1. Now that n I don't know. Are you with me? So this is 6 plus distribute, 7n minus 7. And so I end up with 7n minus 1. Yes? Which is what I started out with over here. Yeah? You see that? Okay? Okay. So we call that a common difference. Now, these kinds right here are called arithmetic. So I have an arithmetic sequence right here, that one right there. Arithmetic is what we can consider or call the linear, o sea, la línea, the linear ones. ¿Sí entienden? So that's like the linear function, right? It's, in other words, if I plotted these values, o sea, de estos valores on a line like this, and I call this A1, A2, A3, etc. Then what would this look like? Well, what is A1? 6, and notice the dots. I only have dots. What do we call this kind of functions that I only have dots? Anybody know? They're called discrete. Okay, so here you have discrete values. Okay, so then I don't connect them. But if I were to connect them, what would I form? I would form a line. So that's what an arithmetic function is. It's a line. It's a linear sequence. Okay? Okay, great. Now let's talk about a second kind of sequence called the alternating sequence right here. So you have the alternating sequence. Why do I call this the alternating sequence? Let's take a look. A sub n equals -1 to the n times 5 over n squared. Notice where n happens. N happens here, and it happens here. So n is the exponent of -1, but it's also the denominator squared, okay? So then remember, I'm gonna take n, plug it in here and here. So what would a sub 1 look like? Well, -1 to the 1 times 5 over 1 squared. That's a 2. This is supposed to be a squared. I don't know why I erased it. Okay, and what is that equal to? Well, what is -1 to the 1? -1. And then what is 5 over 1 squared? 5. So then this is -5. Okay, so what is a sub 2? What is a sub 2? A sub 2, again, I'm going to replace n with 2. So I'm going to have -1 squared times 5 over 2 squared. And that gives me 1, positive 1, because this is squared, times 5 over 4. And so a sub 3, I'm sorry, is -1 cubed times 5 over 3 squared. This is negative again, so then this is a -1 times 5 over 9. So then this is -5 over 9. Same thing with 4. You do your math, you get positive 5 over 16. At the end of the day, you create this sequence. Again, you can do these on your own. You're recording this, so you can just do that, right? Okay, so then this is, again, another sequence. But why is this called an alternating sequence? I'll give you a hint. Where's the alternating? part? Well, it goes from a negative to a positive to a negative to a positive, of course. Okay? And so we call these alternating. What created that, by the way? This right here, this -1 to the n. This is a neat feature. When n is positive, when n is even, this is a positive one. So this would be positive or whatever. It keeps its sign. And if this is odd, then this is negative. And so this changes sign. Make sense? So then you have an alternating sequence, right? And then we have a third kind of sequence called the recursive sequence. For example, this is a recursive sequence. So you start out with 1, 1, 2, 3, 5, 8, etc. How do I find the next term? How would I find this missing term after 34? I would add these two. Notice that to get 2, I add 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8, etc. And so I find that I do 21 plus 34 is 55. This is called, this exact one is called a Fibonacci sequence, a Fibonacci type of recursive. So, but how do you write this? Well, to find an nth term, again, some term, n, the 25th and 1000th term, you simply add the two previous terms. So what do you call the two previous terms? If this is 55, for example, if 34 is a sub n, then 21 would be a sub n minus 1. And 13 would be a sub n minus 2, which is the previous and the one previous to that. So then 13 plus 21, okay? Or 21 plus 13, alrighty? And so we call that, again, the recursive sequence, all right? So let me give you a recursive sequence here. Let me give you an example of one. Suppose that I gave you, and again, I can use n or k. Let me just start over again. That's why I hate pens. Okay. But somebody told me, Mr. Es que no se ve. All right. So what does this recursive formula tell you? What is that asking you to do? To find a k term, what would I do? Add what? Twice the, what would this be? Previous term? And 3 times 2 terms previous. So this minus 2 tells you it's 2 terms previous to this term. This is only 1 term. So if this is the term you want to find, simply take twice the one before it plus 3 times the one before that and add them. And then you would create the next one, and then the next one, and the next one, and the next one. Capiche? Okay, good. Great. Okay, so now, after all of this is said and done, what else do I want to do with sequences? Well, let's start out with, let's go back, I should say, to the, let's go back to the, we'll find more paper. I brought all the scratch paper from La Bouille, and running out of paper. Okay, so again, I have this sequence, all right? I'm going to give you one of the easiest sequence found on Earth. This is a sequence. What's the difference between this sequence and the sequences that I've been giving you? That this is finite. What does finite mean? It ends. So I only gave you 1 to 100. And is this an arithmetic sequence? Of course it is. The only thing I need is to have a common difference. From 1 to 2, I add 1. From 2 to 3, I add 1, I add 1, I add 1, I add 1. So then 1 is your common difference, correct? So then I know that I could write this in 2 different ways. I could write this a sub n and a sub n. If I wrote it, I could write this this way, or I could even say what? A sub n is equal to a sub what? The previous term plus 1. Look at what this is. This is the recursive example. A sub n is what? The previous term plus 1. Think about it. How do I get 5? By taking the previous term, 4, add 1. True? See? Okay, good. And by the way, this is 1. A sub 1 is 1. Plus your common difference is 1 times n minus 1. So then you get 1 plus n minus 1 is simply n. It makes sense that a sub n is n. What is a sub 1? 1. What is a sub 2? 2. What is a sub 10? 10. What is a sub 100? 100. That means that the 100th term, this one, is 100. The 99th term is 99. So it makes sense. Both of these make sense. But now I want to do something to these two guys. Now I want to add. In other words, I want 1 plus 2 plus 3 plus 4, etc. All the way plus 96 plus 97 plus 98 plus 99 plus 100. Now I want to add these terms. Well, there was a famous mathematician who was very young. In fact, he was 6 years old, algo así, según. And in the class, the teacher said, oh, okay, I want you to add the first 100 numbers. Well, Friedrich Gauss came back with the answer in just a matter of minutes. And he came up with the answer, and the teacher was baffled. He said, how the hell? You're not supposed to know those things. And so what did Gauss do? He did this. Instead of adding 1 plus 2 plus 3 plus 4 and then plus 5 and then plus 6 and then wasting time, he started doing 1 plus 100. What is that? 101. 2 plus 99, that's 101. 3 plus 98 is 101. 4 plus 97 is 101. 5 plus 96 is 101. And he said, hey, I am adding 101 how many times? Anybody? How many times am I adding 101? Is it 100 times?
100, yeah. See, no?
Well, but
50,
there's
no?
100 numbers. So how can I be adding this 100 times if I'm adding pairs?
50, okay.
That's right, it's 50. I'm adding 50 pairs. And so sure enough, he came up with the answer 5,050 de volar. Ignore this son. It's Mija who wrote that. All right. So how do you get here then? Well, think about it. First thing you do is you add 1 plus 100. Are you with me or not? You take 1 plus what? 100. You could also add 2 plus 99 or 3 plus 98 or 4 plus 97. Are you with me? But the easiest one to find is 1 plus 100. Are you with me? Well, what does this translate to? Well, 1 is a 1 and 100 is the nth term, is the last term. Well, what do we do after that? Well, we found out how many of these there were. There are how many numbers up here? There were n numbers. So then there's 100, and then I divide it by what? By 2. And so we call this S sub n. What is S sub n? It's the sum of the first n terms. Now, I could have stopped at 92. 1 plus 2 plus 3 plus 4 plus 5 plus all the way to 92. And I can still find that sum by using this simple formula. Right? Any questions with that? No. Okay, good job. All right. So then I got to take you and say, well, suppose that I gave you a sequence. Suppose that I gave you this sequence. And I asked you to find, well, let's find the formula first, and then we'll find the sum, okay? So because of the 3 dots, that implies infinite. So the sequence is infinite. But I can always ask you to find a sum up to a certain point. We call that a partial sum, okay? So, but notice this right here. What's going on with this? 25, 21, 17, 13. This is actually decreasing, isn't it? But is this arithmetic? Of course, because I'm adding -4. And so, how would I do this then? Well, let me write this down. Again, what do I have? I have that a sub 1 is 25. and I need to find D. And again, I just need to do any two consecutive. Say that I do 17 minus 21. It doesn't matter. Just one of them, right minus left. And 17 minus 21, sure enough, is -4. So I have this sequence, AN equals A1, which is 25, plus your common difference, -4, times n minus 1. I do some math. I can go fast because you guys aren't even talking anyway. I needed to see your face after I said that. So what is this? Well, this is the formula. We call this the rule for this sequence. So if n is 1, for example, I get -4 times 1, which is -4, plus 29 is 25. See the first one, right? Okay, good. By the way, can somebody tell me what 29 is?
What do you mean what 29 is?
Yeah, where would
The previous
the
number, the
29
25,
fit here?
before 25.
Yeah, the term right here. The term right here would be 29. In other words, a sub 0. Think about it. If this is 0, then this is 29, right? So a0 is 29. But we started at 1, so that's kind of irrelevant. And I have notes all over the place, so I'm going to jump over here. So there I have this 25, comma 21, comma 17, comma 13, which gave me this rule. Are you with me? Now this thing is infinite, but what if I ask you to find S sub 10? Whoa, what do you mean? Yeah, S sub 10, the S stands for sum. So we're gonna say the sum of the first 10 terms. We'll go back to this formula. Let me take that formula and bring it over here. So it's n over 2 times a1 plus an. So if I were to write this down, I would have how many, what is n here? How many terms are there? 10, correct? And then I would have a1, yeah? I'm looking at this formula here. A1 is 25. What do I not have? What am I missing? What does this say? A what?
N.
The n. What is n?
10.
I don't have a 10, do I? So I need to find a 10, and that's where this formula comes in handy again. So I'm going to put it in here. So that's -4 times 10, 29. What is this? -40 plus 29. This is -11. So there, I found this right here. So there, here I go. Now, listen, sometimes this number, n, is odd. And so I really don't want to divide by 2 and get a decimal, but rather I would wait to add these because then this would have to be even by rule, okay? Now, because this is already even, 10 divided by 2 is 5. 25 minus 11 is what? 14. And I would get what here? 70. So what does 70 represent? The sum of the first 10 terms of this sequence. Now, this sum, okay, this sum, this 25 plus 21 plus 17 plus 13 plus is called, now, it's called the sequence. Are you with me? So it's not called, I'm sorry, not a season. It's not a series. It's now called a series. I apologize. So the sequence is the list. The series is the sum of the terms of the list. Are you with me? All right. Now we're going to translate this into the last part of this lesson, which is called summations. What is a summation? Summation looks like this. Looks like this, I. So this is called summation. This is also known as the sum of. Okay, so down here we're gonna use a letter. Usually the book uses I. I've seen books use J. I've seen books use K. So I, J, K. Books use different letters here. And so we say that I is your index. So it's a good letter for I, or it's a good letter for index, I. So, and then here, I'm going to start at I equals 1. Well, that 1 is really this subscript right here, you know, the A sub n. So I could really actually put I equals 1. I mean, I could put n equals 1, except I want n up here. Okay, of A sub n. This is your series that you want to write down. So how would I write my series, this one, like this? Well, do I have everything? Of course I do. I know to leave this alone, I equals 1, leave that alone. Leave n alone. So what about the rest? I don't know what I'm doing here, guys. Oh, yeah, it disappeared. Okay, well, all I got to do is find A sub n. What is A sub n? Negative 4n plus what? 29. And you're done. This is this right here. One more time. This is this. Think about it. What does this mean? I equals 1. Substitute what first? 1. If you do that, what are you going to get? 25. Now, this means from I equals 1 to I equals n. I don't know what n is. So then this is this infinite series. So what's after 1? 2. So if I plug in 2, I get 21. If I plug in 3, I get 17. If I plug in 4, I get 13. Plug in 5, I get the next one. Plug in 6, etc. So what about the pluses? Am I not adding these? Of course, that's what this means. What does this mean? It means the summation. So after you do 1, you do plus, plug in 2, plus, plug in 3, plus, plug in 4. So then let's do. Dang it, I'm running out of paper. Suppose that I gave you this summation. Let's just use J equals 1 to 4. Everybody see it? So we got J equals 1 to 4, say of 1 over J squared plus 1. Whoa. How do I evaluate this? How do I find the sum? Well, I plug in J equals 1 right here. So I'm going to start out with 1 over 1 squared plus 1. But then what do I do in the middle? Plus, because it's going from 1 to 4. I'm not going from 1 to 1, and that's it. I'm going from 1 to 4. But I don't go 1 and then jump all the way to 4. No, it's from 1 to 4. So what's after 1? 2. So I got to go 1 over and then replace J with 2 squared. And then replace J with 3. And then replace J with 4. So there's your n is 1, n is 2, and I mean J, apologize. J is 1, J is 2, J is 3, and J is 4. And of course, I end up with a fraction, plus a fraction, plus a fraction, plus a fraction. And you got calculators, and you got speed, or you got whatever you need to find that sum. Are you with me? In Calculus 2, which is one of the classes I teach at Community, we learn to add these to infinity. What if I want to add, what is the sum of this thing to infinity? What is the infinite sum? Is it infinity also? Or is it actually a number? And it turns out for this example, it's a number. And what is the number? Sometimes it's really difficult to find. Sometimes it's really easy. If it's what we call, and you'll see in 9.3, we're going to study geometric sequences. And if this is a geometric sequence or a geometric sequence type, then we know what it converges to. Otherwise, we don't know. But we just know it does. It goes to a number, but we don't know what number it is. We just kind of know that it's less than 10, for example. Okay? Okay, great. That concludes the lesson, ladies and